Hey guys, Miss Davis here again. This video will cover Unit 4, Skill 3, Part C. So we're going to do a little bit harder proofs in this video. So go ahead and take a moment to pause the video, write down your essential question. How do we prove triangles are congruent using more involved given statements, okay, or more complicated? So take a moment and write that down. Okay, so I'm going to go ahead and set up my T-chart to save some time. I'm going to pause the video. You go ahead and set up your T-chart and write down your one and only given for this first one. So go ahead and write down your T-chart and your one and only given. Go. Okay, now that you've written down your statement, your reason, and your first and only given, let's just kind of look over off to the side here where it says remember. So just some reminders that a proof is that in a proof, the first statement and reason, the first statement and reason is from the given. And then the last statement is always the proof statement, okay? So we're going to go ahead and we're going to take a look at what we were given. So AE and BD bisect each other. So if they're bisecting each other, that means they're cutting each other in half. So they're cutting each other in half, which means that if we've got C here as that midpoint, and they're cutting each other in half, then that means that BC is going to be congruent to CD. And in this case, we can also say that AC is congruent to CE, because if they're cutting each other in half, that means that AE is cutting BD in half and BD is cutting AE in half, making C that midpoint. So we can go ahead and come up with our second statement here. Because of our bisector given, we can say that AE is congruent to, AC is congruent to CE. And since we're using bisector as the reason for both of these, we can put them on the same line. We can say and BC is congruent to CD. Okay, so do you see how I gave them each one set of tick mark for the one pair of congruent sides or corresponding sides, and then two tick marks for AC and CE to show that those are congruent to each other but not congruent to the other two pieces. So what are we going to write in our given? Well, we use the idea that that was a bisector. Okay, so we're going to define a bisector over here. So our reason for those segments being congruent is that a bisector divides a segment into two congruent segments. Okay, so we always want to make sure you define that vocabulary word after you've used it and applied it to your diagram. So we have ran out of givens, so that one's done, that one's done. And now we need to look for either reflexive, so I'm going to make a little note over here. Remember that we always need to look for those two properties on our own, so vertical angles. Or our second one we need to look for is the reflexive shared side of the two triangles. So in this case, we don't have reflexive, but we do have vertical angles. So right here where those two intersecting lines meet, we've got vertical angles on either side. So I'm going to go ahead and come up with my third statement. If I name that angle right there on the left side of the triangle, the left triangle, if I name it BCA, I can start with that. So angle BCA is congruent to, now when I name my second angle, I have to start with the side that corresponds with angle B. Since I started with B, do you see how angle D is the matching angle that if I rotated that triangle back around 180 degrees around point C, angle D would match up with B. So we're going to do DC, and then E would match up with A. So I'm going to go ahead and say that BCA is congruent to DCE. So the ordering of the letters does matter because we want to make sure our parts are matched up. And one way we can also do that really quickly off to the side, if I write down the two triangles here on top of each other, so if I write ABC and EDC, you should see that angle B and D match up with one another. So B and D are both in the middle. Angle C is next in line there. And then A and E also match up. They're right on top of each other. So that's another way to find your corresponding parts. Okay, so what's my reason for number 3? Vertical angles are congruent. Okay, so off to the side, I'm just going to write down what I have so far, sides or angles that are congruent. So I got 2 pair of sides here. So my one pair of sides was that AC and CE was a pair of sides. I've got another pair of congruent sides, so another S, and I've got a pair of congruent angles. So we know that it can't be that ASS or SSA. We talked about that before. So it has to be, if it's got 2 S's and an A, it's got to be side angle side. Well, let's just go ahead and take a look at our picture. We've got a side for the tick mark, an angle for the arc, and another side for the tick mark. So if I go in order and they're taking that shortest root again, is side angle side. So that means that step 4, I have 3 pieces of evidence. I can then jump down to my triangle congruent statement, which should always be your very last statement, whatever is the proof statement. So triangle ABC is congruent to triangle EDC. And our reason there, number 4, is side angle side. Okay? All right, example number 2 is on the next page, so go ahead and flip on over. Go ahead and write down your first given in your statement column. Okay, so our first given is that segment BD bisects angle ADC. Okay, so if I know that it's bisecting angle ADC, one thing that we can do is highlight that angle, ADC, so from A to D to C, is the angle that's being cut in half by the segment bisector, BD. So what happens when you bisect something? Well, it does what exactly I just said. It cuts it in half. So it's going to bisect or cut the angle that comes right after it in half. Whoa. So that means that where the angle turns, so ADC, sorry, where D is, you're going to have those 2 congruent angles there. Okay, so our next statement can be our conclusion based off the bisector that angle CDB, so this CDB here, is congruent to the angle. Again, we have to start with the angle that matches up with angle C. So it's going to be that reflection ADB. So angle ADB. And what can we say for our reason? Well, we need to use the word bisector, but in this case, we're not going to say it bisects a segment. We're going to say a bisector divides an angle into 2 congruent angles. Okay, we can even say an angle bisector divides an angle into 2 congruent angles. Okay, all right, so our next statement, we have used up that first given. We still have to use our second given, which is that BD is perpendicular to AC. And as soon as we see that, we should be thinking, I need some 90-degree angles. Okay, so I'm going to go ahead and state my second given. So BD, perpendicular to AC. Step 3 is the given. Okay, so wherever we can see where BD meets AC, so I see that BD is right here, and where it meets AC is right here. So right by angle D is going to be or point D is going to be our two 90-degree angles. So step 4, we're going to use our given that they're perpendicular to create those 90-degree angles. So we have to state them. So I'm going to say angle CBD is congruent to angle ABD. Again, always wanting to match up your corresponding angles and sides when we name them. And this is going to be, our reason is going to be because of our perpendicular lines. So I'm going to define what our perpendicular property was there. Perpendicular lines create congruent, what kind of angles? Specifically 90-degree angles. Okay? So far off to the side, do I have enough to prove my triangles are congruent right here? Well, let's see. I have a pair of congruent angles from the angle bisector, and I have a pair of congruent 90-degree angles from our perpendicular lines. So I only have two pieces. So I only have two, so I need one more. Okay, so now I need to go ahead and look for those vertical angles or reflexive property. Hopefully you guys can see that on these two triangles, BD is that shared side again. So we're going to go ahead and use BD as the reflexive side. So BD congruent to BD. Extend that line, 5, is the reflexive property. Okay, so let's see, we have used the reflexive sides to get an S in there for a pair of sides. So let's see which order are they the closest in. I have an angle up at the top, I have the congruent reflexive side, and then I have the 90-degree angle. So shortest route would take me angle, side, angle. So our step 6 is, once we have those three pieces of evidence, take our proof statement and put it down here. So triangle ABD is congruent to triangle CBD. And step 6 is because of angle, side, angle. Okay? Now our last proof is going to be on the 3rd page here, so go ahead and flip on over. And set up, oh, that's already set up for us, so that's good. I'm going to zoom in here. So what I want to do is look at my picture, and let's start by labeling what we have. So all the givens were already set up in the statement column, which is totally fine. So AB is congruent to CD. Let's take a look, put a tick mark on that side and a tick mark on that side. So we want to label with the congruent tick marks. We've got BF perpendicular at AC. So let's take a look at that one. We've got BF right here. I'm going to highlight that side. Is perpendicular at AC. Okay, so where it meets AC, we got perpendicular 90-degree angles. So I'm going to go ahead and draw in those 90-degree angles there. And another perpendicular statement, DE is perpendicular at AC. So I'm going to go ahead and highlight that so you can see that it's DE is perpendicular. So where that DE line meets AC is also going to be a pair of congruent 90-degree angles. Okay. And then our last piece here is that AE is congruent to CF. So AE is this whole segment right here, A all the way to E. Since I skip over that letter F there, I'm going to go and make a bracket and pass it by and show that that side is congruent to CF. So then CF is way over here. I'm skipping over E, and I'm going to put 2 tick marks on that. Okay? So before we keep going, let's take a step back and look at what are we trying to prove, because you see how there's many different triangles in this picture? So I'm going to highlight in a different color, in red, the 2 triangles that we're trying to prove. So you guys take out a highlighter and highlight triangle AFB, which would be AFB, this triangle right there, and triangle CED, which would be CED right there. Okay? So as you can see, we've got our triangles highlighted that we're trying to prove are congruent. So our next step is, before we move on, we want to go ahead and talk about what we haven't talked about yet, which is our congruent 90-degree angles in there. So I've got the 90-degree angle, and we only want to talk about the angles in our proof that are inside of our triangles that we're trying to prove are congruent. So do you see how this 90-degree angle right here is the one we want, and this one here? Okay, so just the ones that are inside of our triangles we're trying to prove are congruent. So step 2, I'm going to name that angle here, this 90-degree angle is BFA. So angle BFA is congruent to angle on the other side, angle B is going to match up to angle D right here. So we're going to start with B and D. So our second angle is DEC. Okay? So for our reason there, we're going to use the perpendicular definition. So perpendicular lines create congruent 90-degree angles. Okay? Okay, so far we need to take a step back and see what we have been given and what we already have, because again, we need 3 pieces of evidence. So is AB, this first given, is this a full side of the triangle, of each triangle? So is AB a full side of the triangle we're trying to prove? And CD? Yes, it is. So this is one pair of sides that are congruent. Now, we also have that pair of congruent 90-degree angles, so we definitely have a side and an angle. And now, do you see how our last given here, that AE congruent to CF, do you see how that length is too long? So this piece right here is too long of a segment to fit our triangle. So it extends past the triangle that we want. We only want from A to F, okay? So we only want from A to F to be congruent to CE. But do you see how if I take the whole segment AE and I get rid of, or if I subtract off this middle piece in here, so if I subtract off this AE from both of those segments, I'm going to end up with just AF and CE. So we're actually going to use what's called the subtraction property. Okay, so the subtraction property right over here is the idea that if you have a whole piece that's too long, we're going to subtract off a part, and then we're going to be left with the part that we want. Okay, and conversely, when we have something where we need to add on segments together, it's called the addition property. So if you were given 2 parts that were too small, you would add them together to get the whole piece that you need for your triangle. So what I like to do is take a look and draw this off to the side. So if I had my whole piece was AE that they gave me. So right here I'm looking again. So AE, if I subtract off the part that I don't need the EF in the middle. So I'm going to go minus EF. When I subtract them, you're going to cross out the letter that repeats. So see how the E's both repeat? You're left with just AF. So AF is actually the side here on our picture that we need it to be just right to fit our diagram. Okay, so then the other side, if I go with my other too long piece, was the C all the way to F. So if I start with CF and I subtract off the middle piece again, is that EF. Then I am going to be left with, if I cross off my repeating letter, is CE. Okay, so CE right there. So that would give us one of the sides of the triangles that we need. So before we can do that, since we're actually subtracting off that middle piece, EF, we have to state it in here that it's a reflexive piece because we're using it in both parts of the triangle, like we're using it to help us prove that the triangles are congruent. So we have to state that EF is congruent to EF because of the reflexive property. Okay, and then after we've done that, we can then say that here's our 2 leftover pieces, the pieces that are just right for our triangle, are AF congruent to CE. And what we say over here on the right is because we use the subtraction property to take our segment that was too long and subtracted off what we didn't need. Okay, so now we've got another pair of congruent sides on our triangle. So I need to figure out what my theorem is. So I've got a side with the tick mark, a side here, and we've got a congruent pair of angles, those 90-degree angles. So if I did follow them in order, it would be ASS if I took the shortest route. But we know we can't use ASS, and as long as it's got the 90-degree angle, then it's a right triangle, and we can use HL, which stands for hypotenuse leg. Okay, so we've got the hypotenuse, the two hypotenuses are congruent, and one of the legs are congruent with the 90-degree angle, which means that by default, they have to be congruent by HL. So triangle AFB is congruent to triangle CED, and our theorem here is HL. Or let's write it out here, hypotenuse, leg. Okay? Alrighty, so that is an example with the subtraction property. Go ahead and try some practice.